Okay, this is my lesson that I'm videoing for evaluating expressions. The students will already be ready to do bell work. It'll be a system set up to keep class management in line so that students are prepared to begin work and to also identify prior knowledge that they have on simple expressions based on the bell work. This will be done as they enter the classroom and as the bell rings, and then I'll do attendance, and then after I'm done, I'll go around and observe the students and maybe point out some steps that they might have missed before we begin working on the bell work that they had completed as a whole class. The objectives that the students will be expected is identify parts of an expression and identify ways to rewrite an expression. Now these objectives will be posted on the board throughout the class so that students can use it to reflect back on what will be expected of them and what they can expect to be able to do upon completing the lesson. The standards for this lesson are HSA, SSE, A1, it's a Common Core standard. Interpret expressions that represent a quantity in terms of its context. And HSA, SSE, A.2, use the structure of an expression to identify ways to rewrite the expression. Now, like I had mentioned, the base for this lesson is to identify something simple that students have already seen. They've already seen simple expressions like this, but to let them know that the expression can be much more than just something simple. Before they might have seen this as just a blank spot and filling it in, but the X is what they are looking for when solving a simple expression like this. So to begin the lesson, we will work on the bell work and cover it, and to hold the students accountable for what they did during this time, that it's not just a time for them to goof off or mess around. We will go into the lesson by covering key vocabulary words. Now, one thing the students will be doing is they'll have personal journals that they will use to take notes, write down examples. These will be used during the lesson, during the unit, throughout the year, that they can use as references to go back and look at what they wrote in their own words for different things. It's a great tool for referencing. So key vocabulary words that they will write down will be expressions, terms, greatest common factor, highest term value, coefficients, variables, and constants. Now, we have a simple expression here, and I've identified the expression, and each part, we've got 3 terms in here. The terms are the 6x, the 3, the 15. Now these are what make up the expression. Where we see a variable, which in this case it's an x, whatever's in front of that, that's the coefficient. And the constants, in this case, would be the 3 and the 15. Those are constant because those never change. Whereas the coefficients, there's a variable involved, and based on what that variable is gonna change what this value will be when we are solving this expression. Now, when we look into an expression like this, what is the terms that make up this expression? The terms are 6 question mark, 3, and 15. Now if you noticed on the bell work I included different expressions. I used a question mark, I used the word cat, I used Y, X, a smiley face. This doesn't matter. This is just telling us that it's something. You know, it can be whatever we want. Most of the time we use letters just because that's a common practice in mathematics. Okay, so like I mentioned, the 3 terms here make up the expression. Now what are the constants in this expression? The constants in this expression are 3 and 15. And the coefficient is 6, where the question mark, that is our variable that we will be solving for. Now in this one, we have 4 smiley face plus 8 equals 20. Now, it's similar to this in that we have 3 terms of the expression, but the other thing that I want to touch on is the greatest common factor. Now what we use the greatest common factor for is to help simplify an expression. Now these are basic expressions, but in both of them we can simplify them further to help solve for the variable. So the first step when we're solving for an expression, we want to be able to simplify it because of the fact that a lot of the time with larger numbers we can experience maybe miscalculation or something like that. So if we can simplify it, we can reduce the amount of errors if we can get it down to its simplest form. So for this expression, I've simplified it. The greatest common factor in this expression, we have a 4, an 8, and a 20. Well, 4 goes into each of these. It goes into itself once, it goes into 8 twice, and it goes into 25 times. So it would be written as 1 smiley face plus 2 equals 5. Now when we solve for the smiley face, we're going to subtract 2 from both sides. This, by subtracting on this side, it'll cancel out. 5 minus 2 leaves us with 3. So 1 smiley face equals 3. Now, if we plug that back in to the original expression, we have 4 times 6 plus 8 equals 20. 4 times 6, excuse me, this is a 3. 4 times 3 equals 12. 12 plus 8, that equals 20. So we know that that checks out. And once again, we simplified this expression to help get the answer for the variable going into checking in our original expression. Like I said, the greatest common factor for the purposes of this lesson and this unit will be just to simplify the expression into something easier to work with. Okay, so if we look at the example problem in our book, it gives us a word problem. It says that a theme park wants to know how much revenue to expect based on attendance. The revenue can be found with the following expression. It says 2R plus 4 is the expression used to find the revenue based on attendance. So the R is the number of people that enter the park. So if we evaluate this, when R equals 8, R equals 15, and R equals 26, we'll have R equals 8. That is 2 times 8 plus 4. 2 times 8, using order of operations, is 16 plus 4 equals 20. That is the equivalent of $20. Now, we'll do the same thing with 15. R is our variable in the expression. We have two terms in the expression. So when R equals 15, we have 2 times 15 plus 4, order of operations, 30 plus 4 equals 34, or $34. Now, we'll do it again, same thing with 26. R equals 26. The expression says 2 times 26 plus 4 equals 2 times 26, that's 52, plus 4 equals 56, or $56. So we've seen a word problem where it had asked us to solve an expression with given numbers for the variable in that expression. So if 8 people attend the park, the revenue for the park will be $20. If 15 people come to the park that day, it'll be $34. If 26 people come, the park will expect to receive $56 in revenue for the attendance of the 26 people. Okay, so we know that an expression is made up of terms, and there's variables inside the expression, and that is what we are looking for to solve the expression. So to check for understanding, I'll have two explanations from the students, and then I will have them solve 3 equations with expressions and go around and check for understanding. So I will have 2x squared plus 4x minus 6 equals 15. Okay, so here's our expression on the board. And I want to know, what are the terms of the expression? Student will explain what the terms are. Based on their answer, I'll call on another student. Do you agree with what student A said? Why or why not? If there's still something missing, I'll call on a third student. Student C, explain why you do not agree with what they said. What I'm looking for is, what are the key terms for this expression? 2x squared, 4x, 6, and 15. Those are the 4 terms that we're looking for. I want to be able for the students to identify, build on them. If they mention just a couple of them, okay, that was good, but I would like to know what is your feelings on what do you want to add to this? Okay, that's good. I want to keep a positive influence on their answers to keep building them up. Okay, then I'll call on another student. Explain what an expression is. Now we kind of touched on it with this, so then the students, it'll kind of lead them into that. I'll call on a different student and they'll explain. I will ask another student, do you agree with what they said? Yes or no? Okay, so what we have is we have an expression that is made up of terms. Inside the expression we have coefficients, which are in front of our variables, and we have constants. Okay? So we know that with these different variables, coefficients, constants, that makes up our expression. Okay, so the final piece will be for the students to solve for the variables in these 3 expressions. Okay, so I've put 3 expressions on the board, and I will have the students work independently on this, and at this time I will walk around the room and I will observe them and give them feedback for what they have written down. They can use their shoulder neighbor to work with, to work through these problems, but this checking for understanding will lead into the next lesson.